1.1, chapter 1 is all about solving equations, and that's what we're going to be looking at. And let's skip that video there. There's a link on Canvas if you want to get on Canvas and watch some video. I don't even remember what it is, but I think we're ready to just jump in. So we've got 3 objectives today. One is to solve linear equations using addition and subtraction. Again, one-step equations, right? Objective 2 is solve using multiplication and division. And then we're going to do some word problems. Now, just a heads up on the word problems, a lot of you can make sense of it just in your head and be like, oh yeah, just grab your calculator real quick and punch the numbers in and you're done. What I'm going to force you to do is to write an equation, because we need practice writing equations and thinking about things algebraically and using a variable for what we're trying to find out. So just a heads up on those word problems. We're going to be writing equations. Let's see here. Example 1. It says to solve the problem. And notice on a solve problem, we've got a variable and we've got an equation. Well, today what we're going to be doing is we're going to be using inverse operations. So what I mean by that is we need to get x by itself. But what's over there with the x? The -3 or a -3. I think about it both ways, yeah. How are we going to undo a -3? Add a 3. Yeah, so let's add a 3 here. But as soon as we do that, our equation's unbalanced. How are we going to balance it back out? Add 3 to the other side. And by the way, that's called the addition property of equality. We just don't normally say that every time. But we add 3 on both sides. And do you agree that a -3 plus a 3 is 0? And 0 plus x, isn't that just x? And what's 5 plus 3? Oh, by the way, could you guys get out a calculator? If you got your calculator today, go ahead and get that out, because there's going to be a need for it pretty quick. Yeah. And actually, we won't need a calculator on that one. But the next one, we might. Yeah. And some other ones, yeah. So I do have a few calculators for those of you that don't have them yet. But I tell you what, by Monday, can everybody have a calculator? If you don't have a calculator by Monday, I'm probably going to ask you, like, or maybe I'll send you an email. I don't want to make anybody uncomfortable, but I'll ask if you need a calculator, and I'll try to get you one. You want to borrow one today? Yeah, I'll try to get you one to use. You're welcome. Yeah. So if you're borrowing one today, please make sure to put it on my desk when we're all done, because I need to hold on to them. I don't have very many. All right. So example B. What are you going to do to get y by itself? Subtract the 2.8. What do you got to do to balance it out? Subtract the 2.8 on the other side of the equation, right? Well, 2.8 minus 2.8, that's 0. Y plus 0 is y. And then help me out. What is 0.9 minus 2.8? Oh, not quite. Is it negative 1.9? Yeah. Are you guys cool with that? Negative 1.9. And if it bothers you having it written kind of backwards, you can just flip it around if you want. You can write y equals negative 1.9 if you would rather. Oh, by the way, could you check your answers on these to make sure you're right? I mean, these are pretty simple, right? But you could check your answers. Go 8 minus 3. Does that equal 5? Do negative 1.9 plus 2.8. Punch that in the calculator. 0.9. And we know for certain that we're good. Are you guys okay to move on to multiplying and dividing? Okay. So example 2 here, solve each of the following. Now, we are going to do example A in one step, okay? We're going to do it in one step. Let me zoom in a little bit here. All right, so in one step, how can we get n by itself? Well, let's think about it 2 ways. To get n by itself, do you agree that we're going to have to get rid of this negative somehow? Yeah. But do we also need to get rid of this 5 somehow? So there's a way to do this in one step. How do we undo dividing by 5? Multiplying by 5. So I'm going to go ahead and write multiply by 5. And when I do that, I use parentheses like that. Now, right now it's imbalanced, right? So I'm going to balance it out. I'm going to multiply by a 5 on the other side. Now that undoes the 5, but don't I also need to undo this negative? Well, how can we make a negative positive? So I'm multiplying by 5. I'm not going to be adding anything. But it turns out I can multiply by something to get rid of a negative. What's a negative times a negative?
Positive.
So guess what I'm going to do here? I'm not going to multiply by 5 on both sides. I'm going to multiply by a negative 5 on both sides. Now, I'll be perfectly honest. You could do this in 2 steps. Get rid of the 5 and then have that negative and like divide the negative over or something like that. But I'm going to do it in one step. I'm going to multiply by a negative 5 because this negative 5, this negative times this negative makes a positive, and these 5s divide out to make 1. But what's 1 times n? N. And what's negative 3 times negative 5? Positive 15. Now I'm going to go ahead and box it in, but could you check your answer there and make sure it's right? You could, couldn't you? 15 divided by 5 is 3. We got a negative out front, negative 3. Negative 3 equals negative 3. Look at example B there. So we've got pi involved here. Are you guys familiar with pi? What's that?
3.14.
Oh, 3.14. So 3.14 is pi rounded to the nearest hundred. And that's common. That's the one I remember that. But pi is funny. Does anybody remember how pi is calculated? So you take pi is entirely related to circles. But if you take a circle, you take its circumference, you measure around the circle, and you divide by its diameter, the distance across the circle through the center, you get pi. And what's funny about it is pi's decimals go on forever. Did you guys remember that about it? It's irrational. Irrational means that the decimals go on forever. It can't be written as a fraction. I used to think that pi was like the only irrational number. Turns out there's billions of them. Yeah. Basically, anytime you square root a number that's not a perfect square, like square root of 7, do you guys want to punch that in your calculator super quick? Square root of 7. The decimal's ugly. It goes on, it goes to the end of the screen, doesn't it? In truth, it goes on forever, just like pi. So I just kind of wanted to share that with you, that pi is not the only irrational number. There's actually a ton of them, But back to this problem at hand, where's our variable? We've got 2 pi's going on, but what's our variable here? We're trying to get that x by itself, aren't we? And what's right next to the x? The pi, yeah, the pi. And what operation is it when they're right by each other like that? Is it addition, subtraction, multiplication, or division? It's multiplication when they're right by each other. So how are we going to undo multiplying by pi? We are going to divide by pi. And to keep it balanced, we're going to divide the pi to the other side. Pi divided by pi is 1. 1 times x is x. On the other side, 2 pi divided by pi, what happens to the pi's? They divide out to make a 1. Negative 2 times 1 is negative 2. And by the way, you could check your answer here and realize, oh yeah, negative 2 times pi is negative 2 pi. Negative 2 pi is negative 2 pi. Questions so far? Why don't you all do the next one, and I'll come around and check. So, and I do this almost daily, but I'll have a problem where you work it out, and I come around and I give you a smiley face if you have it right. Or if you have it wrong, I'll say, oh, you're close. I usually won't tell you what you did wrong right away, because usually if you have a second to think about it, you can figure it out. But as soon as you got an answer for C, raise your hand so I can come by and see if you're right. If I give you a smiley face, go ahead and read through the next little box in there and prepare for the last few problems. So do me a favor, and it looks like you had the Z there. Go ahead and keep it a Z because that's what we started with. It's not a huge deal, but it's just, well, okay, so later on in some upper level algebra, you'll have more than one variable, and you want to make sure you use the right variable. Okay, I almost got to everybody, almost. I think we're all on the right path though. So this is 1.3 times Z. And to undo that 1.3, what are we gonna do? Divide by 1.3. Now we gotta keep it balanced though. We gotta keep it balanced. If we're dividing 1.3 on one side, we gotta divide by 1.3 on the other side, or else it won't be accurate. It won't be balanced. And if you punch that into your calculator, what do you get? 4. And I will encourage you on a problem like this, go ahead and test it real quick. Go 1.3 times 4 and just double check and make sure you did it right. A common mistake here is to subtract a 1.3 because you just are in that mindset of, okay, it's addition and subtraction, just subtract the 1.3. But we got to think about what operation these are actually doing when they're right by each other. and that is multiplication. So the inverse operation is division. How do you guys feel about this stuff so far? We good? All right, we're ready to go on? So what we're going to do is we're going to have some real life situations here, and we are going to, there we go, some real life situations. And sorry, I got to move this over some. We'll get there. There we are. All right. So it says steps to writing and using an equation to solve problems. So we got a 4-step process here we're going to look at. So step 1, figure out what you know and what you need to know. So start there. What do I know? What am I trying to find out? Define a variable for what you need to know. So whatever you're trying to find out, that's going to be your variable. Write an equation and solve the equation. Okay, so my poor document camera can't hold the weight of my phone anymore. It's getting old, just like me. It's okay. There we go. It's a little better. All right. So for example 3, it says they're talking about Usain Bolt, and he won a 200-meter dash with a time of 19.32 seconds. And it says write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Well, I got to be honest with you. They're kind of giving you a hint here. First things first, how many decimal places is the nearest hundredth? How many decimal places will that be? It's 2, isn't it? Decimal places go point, and then it's the tenths place, and then the hundredths place. So we know we're going to have 2 decimal places. But I'm also going to point out they want our answer to be in meters per second. Another way to think of that is meters divided by seconds. And that's actually a big clue to what we're going to be doing on this problem. We're going to take meters and divide by seconds to get our answer. Now, I'm going to show you another way to think about it. So it says that it was a 200-meter dash with a time of 19.32 seconds, and we want to find the average speed. I'm going to introduce you to a formula that comes up a lot in algebra, and it's distance equals rate times time. Have you guys seen that before? Distance equals rate times time. That's the way I'm going to approach this problem, and I want you to do the same, okay? I know I kind of gave you a cheat there on how to get the answer, but I'm going to use this equation to help us get our answer. So this formula, D stands for distance. So what is the distance? 200 meters. So we're going to fill that in, 200 meters. What is R? So R stands for rate. Do you guys know another name for rate? Rate and speed are usually the same thing. Rate and speed are often the same, same thing. They're equivalent. So we're actually trying to find the average speed, aren't we? So here's what I'm going to do. I'm going to put an X there. We don't know what the rate is. We're trying to find it. And lastly, what does T stand for? Time. And in this case, what's our time? Yep. And I'm going to do parentheses 19.32 seconds. Now, the reason I do the parentheses is because doesn't that say that we're multiplying here? Well, ladies and gentlemen, what do we do to get x by itself? Divide. Yep, we're going to divide it. So divide by 19.32 seconds. Divide by 19.32 seconds. And what is Usain Bolt's speed to 2 decimal places? What do you get? To 2 decimal places. Anybody? Yeah, Xavier?
10.35.
10.35. Yep, 10.35. It did go on, but rounding to the nearest hundredth, it's 10.35. And notice our units here are meters per second. 10.35 meters per second. So, the next example is still talking about Mr. Bolt, but this time he's going to run 400 meters at the same average speed that he ran the 200 meters. How long would it take him to run 400 meters? Now, here's the thing. How many of you know a quick way to do this problem? Raise your hand if you know a super quick way to do this. Xavier?
The average speed times 400.
The average speed times 400. Oh, so we had the average speed from earlier times 400. Oh, and then, so that will get you, oh yeah, speed times time equals distance. I'm not sure if that is going to quite work out. If we do the average speed times the distance, I don't think that'll quite get us our answer. But it turns out there's a pretty straightforward way if you just compare the two problems. Somebody over here had their hand up. Oh, okay, yeah.
The 19.32 times 2.
Yeah, because if it was 19.32 seconds to do the 200 and he's running the same speed, isn't it just going to be double to do the 400? That is totally the easy way to do this problem. But I do want you to check this out. We can still use distance equals rate times time. So even though you got the answer nicely, will you guys practice this real quick? Distance equals rate times time. What's our new distance now? 400 meters. What's the speed that we had from before? 19.32 was the time. So the speed from before was 10.35. 10.35 meters per second. And then what are we trying to find? We're trying to find the new time, aren't we? The time for this. So we can either leave it as t or we could put x here. And doing it this way, what would you do to get x by itself? Divide by 10.35. Divide by 10.35. Now what's interesting is if I keep the units, meters per second, what's going to happen is the meters will divide out and we're going to be left with seconds. So help me out. What is 400 divided by 10.35? So what's interesting is, check this out. If I round it, what's my answer? 38.6 what? 0.65. which is a little bit different than just doubling, right? The doubling. Now, the reason why it doesn't quite match is, didn't I round somewhere? I rounded somewhere. So our answers don't quite match. But on a problem like this, I'd have to accept both answers, if that kind of makes sense. But in this case, by using the 10.35, which was a rounded answer, we got 38.65 seconds. Now, again, I just want to be clear that if you just double this time from before, you get 38.64. I would totally accept that answer as well. It just turns out that if you write out the equation and use the answer you got from before, it gets you a slightly different answer. Looks like I'm going to answer this. Mr. Eichen speaking. So I believe so. I'll be honest with you, I forgot to take roll. And then I just looked and saw that nobody had been absent the hour before. So I can't say with total confidence that he was there. Yeah. Oh, yeah. No, you're right. You're right. You're totally right. And I totally don't remember seeing her yet. Sorry. Yeah, bye. Okay. So, ladies and gentlemen, are you guys cool with that one?
Yeah.
Yeah, you're cool? So on this next one, it's an interesting problem. And by the way, these examples I think were taken from our book, and they're accurate examples. It's real data. And so I thought this problem was kind of interesting. On January 22nd, 1943, the temperature in Spearfish, South Dakota, which, by the way, now that I think about it, I think I know a guy that lives in Whitefish. But I think it's, no, okay. Anyway, but the temperature in South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m. Do you guys realize that it's just 27 minutes later and it dropped from 54 degrees to negative 4 degrees? And the question is, how many degrees did the temperature fall? Now, I agree most of you aren't going to usually write an equation for this. You're going to kind of think it through and be like, oh, okay, what is this? But I want to write an equation. So here's how I want you to think about it. There's a starting temperature, isn't there? And then what does the temperature do? It drops some amount, right? Some amount, it's falling. So there's a temperature fall, and then we end up at an end temperature. So we started somewhere, the temperature fell, and we ended up at an end temperature. Now, I'm just writing it this way so we can write an equation and solve an equation. What was the starting temperature? 54, and we'll keep the units in here, degrees Fahrenheit. Subtracting, do we know how much the temperature fell? Well, yeah, but right now, let's not act like we know the answer yet. We don't know. We're trying to find that, right? So I'm going to make that X. And do we know what the end temperature was? Negative 4. So I want us to solve this equation. Now, a lot of you have the answer already because you know that to go from 54 to negative 4, we had to go drop 54 to get to 0 and then drop 4 more. But we're going to solve this equation to figure it out. And I want you to write that equation out as well, because this equation actually has a bit of a twist to it. We're trying to get x by itself, correct? Well, to get x by itself, we're going to have to undo this 54. But we're also going to have to undo this minus sign. Now, a common mistake here is that people think that adding a 54 will undo this 54. But let's think about that for a second. If I added a 54 right here, would that get us 0? It would not. So here's what I want you to do. I want you to subtract a 54 on both sides to keep it balanced. And I want you to, so this would be 0, right? 0 minus x. Well, 0 minus x is negative x. So it turns out this is not a two-step equation. This is a one-step equation. I'm sorry, this is not a one-step. I had that backwards. This is not a one-step equation. This is a two-step equation. Do you guys know how to handle when it's just a negative out front? How to undo it? You can multiply by a -1. Turns out that's not the only thing you can do. You can divide by a -1. You can do either one of those and it will undo the negative. Do you guys agree that a negative times a negative is a positive? Do you agree that a negative divided by a negative is a positive? Yeah? So you can multiply by a -1 or you can divide by a -1. And either way, you'll end up with x is equal to 58 degrees Fahrenheit. Okay, so they want you to try this next one on your own. Now, I know a lot of you won't want to write an equation, but force yourself to think of a variable and write an equation, okay? So on this one here, on your own, write an equation for this. I'll be honest, it's kind of difficult to write a word setup for this. I kind of went right to an equation when I worked this one out. But think about how to write an equation for this situation. Do you guys mind if I check your answer on this one? No, but you can go to the office and call. Do you want to go to the office? Yeah. Okay. Can I check? Yeah. Oh, hey, by the way, will you guys put a $sign next to your answer? Because it is dollars. And I know this thing is picky. Person in the front. Yeah, look at the hip. Okay, interesting. So you set it up just fine. I just got a slightly different answer. Okay, but you set it up correct. Nice equations, everybody. Normally I have to kind of convince people to write equations, but for the most part, you guys are doing exactly the right requested thing to do. Exactly. You're doing great. While we're finishing up, the equation I wrote was basically, this is how I thought about it was, I think that I have $68, but what did I forget? Apparently I missed a what? A check, right? Well, it says I forgot to record a check. Do I know how much that is? But I know that that check's gonna drop this down, isn't it? And what should my balance be? 26. So I went straight to an equation like that just to kind of walk through it. And almost everybody that I checked had this same thought process as me, which is pretty amazing actually. But to get this x by itself, I'm going to subtract the 68 over. And then I'll get negative 42. But what do I got to do? Get rid of that negative. And it turns out I missed a $42 check. I missed a $42 check. So,